this video, we are going to learn what exactly the graph coloring is and what is the chromatic number of a graph. So beginning with the coloring of a simple graph. So basically it is an assignment of a color to each vertex of the graph so that no two adjacent vertices are assigned the same color. Means we need to color the vertex of the graph in such a way that no two adjacent vertices are having the same color. However, for a graph, a coloring can be found that uses a fewer color than the number of vertices in this graph. The such concept comes under the chromatic number. So, chromatic number of a graph means we need to assign a minimum number of a colors to the vertices such that no two adjacent vertices are with same color. And generally, the chromatic number of a graph is denoted by the chi. So let's understand this with an example. In this example, we have two different graphs. Suppose this graph is G and this graph is named as H. So we need to find the chromatic number of these two graphs. So let's assign the different colors to the vertices provided with the one condition that no two adjacent vertices are having a same color. And let's try to color these vertices with the minimum number of colors. Suppose if I assign this vertex as a yellow color, it means I cannot assign this vertex as a yellow, and same for this one. Therefore, we are going to assign this vertex as the green. Now, point is, can we assign this vertex as a yellow or a green? Answer is no. So, therefore, we need to choose some different color. Suppose we have assigned this vertex as the red color. Now, can I assign this vertex as the red color or a green color? So no, because this vertex is adjacent with the green color vertex and as well as the red color vertex. But we can use the previous assigned color, that is the yellow over here. Now which color we can assign to this vertex? Can we assign the color yellow to this vertex? So answer is no, because it is already adjacent with the yellow color vertex. Now can you assign red color to this? So yes, even we can assign green color. So right now I am assigning this vertex as the red color. From here we can conclude that total number of color used in this graph is 3 and that is the minimum count. Therefore its chromatic number is 3. Now let's find the chromatic number for the graph H. Suppose we are assigning yellow color to this vertex. Therefore, we cannot assign this vertex as a yellow and as well as for this vertex as a yellow. But we can assign a yellow color either to this vertex or this vertex because these two vertices are not adjacent with this vertex. Suppose we are assigning a yellow color to this vertex. Now moving further, assign this vertex as the red. It means we cannot assign this vertex as a red color. Even in this case, we cannot assign the red color. Let's assign this vertex as the blue color. Now, can we assign a red or a blue color or yellow color to this vertex? So, answer is no. Suppose we are taking the white color to color this vertex. Now, according to this, the total number of color used in this case is 4. But this is the least number of color used in this case? You can check it. Graph G is a subgraph of the graph H. It means if you assign the same color format as assigned in a graph G, whether it fulfills our condition that no two adjacent vertices are having a same color. So you can observe that rather than this, if you assign color in this format, yellow over here, green, red, yellow, rather than taking yellow over here, if you are assigning this vertex as a yellow, then we can use the red color over here again. It means we can color the graph H in a various way, but we need to use the least number of colors. In this case, we are getting a 4 colors, whereas in the following case, we are getting a 3 color used in this graph. Therefore, the chromatic number of the graph is 3, as that is the least number of color used to color the vertices such that no two adjacent vertices are assigned same color. Next is four color theorem that is related to the chromatic number, and that is for the planar graph. It says that the chromatic number of the planar graph is no greater than 4, or we can rephrase this as every planar graph is 4 colorable. So it means if the graph is planar graph means if you reconstruct the graph in such a way that there is a no intersection of the edges. According to the four color theorem, the chromatic number of the planar graph is always less than equal to 4. It cannot exceed 4. It means if the graph is planar, then the chromatic number of that graph is equal to either 1 or 2 or 3 or 4, but cannot be greater than 4. For example, in the previous case, these two graphs are planar because there is a no intersection of the edges. And in this case, the chromatic number of the graph is less than equal to 4.